Welcome back. We're going to process our data that we found from our sodium ion by ion exchange lab that we did. Let's take a look first at the data sheet because you didn't fill in very much, did you? There's the stuff we did last time. So when we take a look at our data sheet, there are pretty much only two things you filled in. Well, a couple things. First of all, I think you'll have an unknown letter. And second thing, the molarity of the standardized NaOH that you actually used. This is mine. Third, the volume of NaOH that you used, and fourth, the volume of NaOH that you started with. Okay, now let's really quickly remind ourselves what we did. Let me find a nice blank sheet. What we did, first of all, was take 25 milliliters exactly of an unknown sodium solution and dilute it. We put it in a 250 milliliter vol flask and diluted it with water. Okay, so we went from 25 to 250. So we're going to be using M1V1 equals M2V2 somewhere. Okay, then we took 50 exactly milliliter aliquots of this diluted solution and put them on the ion exchange column. And we let it drain into, or we caught the eluent. And the eluent was going to have the H plus that was released from the ion exchange resin by the sodium. Okay, the sodium, remember, replaced that H plus. So we caught the eluent and then we rinsed it thoroughly with water and caught the rinses. Finally, we titrated the flask, this flask, with standard NaOH to determine the moles of NaOH, which is the same as the moles of hydrogen ion that were pushed off the column, which is the same as the moles of Na+. So let's go ahead and get started on some of these calculations. So I already showed you what we have. The only numbers we have are from the burette. Remember, the burette had to be read to 2 decimal places. Okay, so we're going to recall that the stoichiometry of NaOH to HCl is 1 to 1, and we're going to calculate the number of moles of HCl eluted. So here we go. There is our volume in liters. Where did we get that from? Well, we subtracted these two, and there it was. Converted it to liters. Okay, so that many liters times the concentration of the standardized base. This was 0.01860 molar or 0.01860 moles per liter. So that cancels our liters. So now we're in moles, and I should have written in there of NaOH. Now, because this is a 1-to-1, the next thing we do is convert it. 1 mole of NaOH to 1 mole of hydrogen, and our moles of NaOH cancel. And finally, we're going to end up with our moles of H+. Okay, so now we can go ahead and fill that line in, and there we have it. So now we need to know how many moles of hydrogen were titrated, and that, remember, was 1-to-1, so it's the same number. Okay, step 3. From equation 2, we know that the sodium ion in the sample solutions is exchanged 1-to-1 with a hydrogen ion from the resin. Therefore, moles of hydrogen should equal moles of sodium, or moles of HCl, moles of NaCl. So we're going to be finding the moles of NaCl in that 50 milliliter sample that we put on the column. So first things first, the moles of Na plus that were in the sample, 1-to-1-to-1. So it's the same number. Now we're going to be doing the molarity. And now we have to find its molarity. So we have that moles of Na plus, and again, it was a 50 milliliter sample that you put on the column. Exactly 50 milliliters. Remember, you took your 50 milliliter pipette and put it into the solution into a clean, dry little beaker. Put that on the column slowly and gently because you didn't want it to overflow. And then once you had that all on the column, you put lots and lots of water on to make sure that you got all that H plus that had been exchanged off. But all that water that you were getting, that you were flushing it with, didn't matter. What mattered was that you had only put in salt, Na plus, from that 50 milliliter sample. So the concentration was simply 0.0004929 moles of Na plus divided by that 50 milliliters in liters, keeping the correct number of significant figures. And now you have the molarity, which you'll also fill in right there. Okay? Now that was pretty much all you had to do. But you did it 3 times, right? You had 3 samples that came off that column, and you did 3 titrations. So let's come down here and see what we had. Well, this again was mine. So I had 3 titrations, and they were pretty good, and they should be very close. And your volumes should be very close. Okay, your volume should be very close because you should, in theory, be titrating the exact same amount of eluent every time. So once I got my 3 molarities, I averaged them. Okay? The only thing we have left to do is to remember that originally we had diluted this. We had 25 milliliters that we had put into 250 milliliters. So this required us to use that good old standby equation, M1V1 equals M2V2. Now we just found M2, we knew V2, and we knew V1. So all we're solving for now is M1. So we're going to simply take our M2, like I said, times the second volume, which was 250 milliliters or 0.250 liters, and that equals M2, which we're looking for, times the 25 milliliters that we originally used. This gives us our M2 of 0.09833, which is the last thing we enter on our data sheet. Okay, so your calculations are done. So now we get to the questions, which is your post-lab for this week. And the only difference between what you did and what this is that you use in the questions calcium chloride. And that we're doing an anion exchange this time. So this time we have all those little beads that have OH on them, and you put the calcium, the chlorine in, calcium chloride in, and off it comes. You will then find the concentration of or the number of moles of hydroxide, same way we found the moles of hydrogen, which would give you the moles of chloride. But now comes the twist. We want to find the moles of calcium chloride. So think about that. Is this 1-to-1? All right, have a good week, and we'll see you next week.